we actually were able to analyze and measure the passage of an Arctic cyclone.
And this occurred at a time period when there was quite a bit of complete cover of sea ice, and then the cyclone built and developed itself over in Eurasia, and it spun and came across northern Alaska, and it fractured the ice across that area. In doing so, it also brought wind down into the foothills of Alaska, where we were able to capture this event in real time because the isotope properties had changed.
Those isotope values were very distinct from what had occurred just a couple days before and a couple days after the passage of this Arctic cyclone.
The last couple nights it's been a little chilly, and so there's ice is crusted over a lot of things here. So it's collecting data right now, and there's mixing of different layers. The water vapor concentration could be mixing right now, and we can't see it. The instrument is able to detect that, and that's really neat.
What we discovered is we're actually able to monitor Arctic sea ice conditions 100 miles south of the actual Arctic coast and do this in real time.
You can see that data are coming in approximately every second. There's a new line of data, and we have it programmed so it'll collect from one valve for about 5 minutes, then switch to another valve, and then it rotates all the way through that. Even when you're sleeping, it's collecting data for us and helping us understand what's going on.
When you evaporate water off of an ocean that's covered in ice, its chemistry is very different compared to water that evaporates off an open body or a fractured body of water.
What was once capped before is now open, so there's energy that is essentially changing the pressure gradients in the atmosphere that is in turn impacting the location of the jet stream.
And what we discovered is this remarkable change associated with a closed Arctic Ocean to now an open Arctic Ocean associated with the cyclone is actually repeated in the Greenland ice core. And the Greenland ice core record, people had postulated that some of that variability was associated with retreat of the sea ice around Greenland and an increase in warmer water and open water sources from the south. And our results in this real-time monitoring actually confirmed this interpretation of the Greenland ice core.